supposed to be cold? I haven't really paid much attention.
Yes, to be.
Alright, well, maybe. Alright, so, first of all, some of you weren't sure what this stuff was. This is just telling you x is not allowed to be -3, because if I put a -3 in the denominator, what happens? We get that 0, right? That's all that is. So you don't have to worry about that thing. Okay, it's called a restriction on the variable. Alright? Or on our domain. So our domain is all real numbers but -3. Okay? So remember, we're thinking this is our y equals, right? We talked about yesterday. We're thinking that's that y. Right? And then to do this, what do I do with the x's and the y's? I switch them. So this becomes x equals 2y minus 1 over y plus 3. Okay, Beard? You were just writing anything down in the last couple. I know, I can tell. You think I'm some old friend, right? It's not very nice to think of it that way. All right, so how do I get this y plus 3 out of there? What's being done to it right now? What's that mean? Divide. So to move it, I gotta multiply, right? So I'm gonna multiply, both sides by, y plus 3. Okay? So what happens over here is those will cancel. Okay? So I've got this. Let's go back to red now. All right, I've got, if I distribute, I've got xy plus 3x equals 2y minus 1. You guys okay with that? All I did is to get that y plus 3 out of the denominator. Remember, that's division. A fraction, that's a division problem. I could do multiplication, right? You guys know that. Then I distributed that x times the y plus 3. Okay, remember, my goal is to get y by itself. I have one on each side. Okay? So I'm going to get the y's on the same side and everything else on the other side. Okay? I can take the xy over there, I can take the 2y over here, it doesn't matter. How am I gonna, I'm just gonna say this 2y, I'm gonna move it. So how do I move that to the other side? Now I subtract it. Now you guys know the rules for solving equations, right? Okay, I'll just do one step at a time instead of do more than one. So I got xy minus 2y plus 3x equals -1 now, because those cancel, right? We okay so far? All right, so I've got the y's on the left, so anything that doesn't have a y, I want to get over there. So I have to move this 3x over. How do I move it? Subtract it, right? Okay, so what gets some of you is you just see all these letters and not a bunch of numbers, and you're not sure what to do. It's the same rules, even though it's letters and not numbers, okay? Again, this order really doesn't matter. I just like putting the variable in front. You did -1 minus 3x, that's okay. That's not wrong. All right, so here's what you got to do when you have this situation. We want to get y by itself. That means we want one y, right? But I got two y's right now. Okay, so the way I turn two y's into one y is I think of a GCF. All right, I factor out the y as a GCF. Okay, that's where, from here to here is where some of you get stuck. Because you see, you gotta get y by itself, and it should just be a single y, and there's more than one showing up. Okay? So what you do to make it into one y, it's factored out as a GCF. So remember, this means y times x minus 2. So how do I move the x minus 2 over? Divide, right? So I'm going to divide by the x minus 2. So my answer then, my inverse, is this negative 3x minus 1 over x minus 2. Okay? Now, we could write it like this if you want. You don't have to, though. That means the inverse function, right? But if you just leave it y like I did, that's okay. Now, I didn't talk about this yesterday, and I'm not really going to worry about it, I don't think. Maybe I did. On your quiz, I don't remember right now, but usually I make you guys, and I know I did last year, talk about restrictions. What can x be? 2, right? So I should add there, x can't be 2. Put that restriction on our domain when we find our inverse. Mr. Boston, you could teach this for me, couldn't you?
I could. It wouldn't be nearly as fun as the
I don't know about that.
Just remember, you use algebra every day of your life. We'll stop asking.
Mm-hmm.
Middle school, are they going to go wrestle Friday against Hoover?
I asked him, but he never said yes.
He told me the coaches spoke and we're going to wrestle.
Oh, they never got back to me.
Okay.
I'll have to ask him that. Okay.
Yeah, he's going to set it up and send me ticketing info.
Okay. Are they streaming too?
I'll ask him.
Yeah, that's what I was going to ask you.
Okay. I'll figure it out.
All right, that'd be good because our middle school guys would like to get a couple more before Saturday's their last one.
All right.
All right, thanks.
He said 5:30.
Over 5:30 start for them?
Yep.
Okay. Thanks. Okay, so again, these were like the last 3 or 4. This one was. Some of you I know weren't quite sure how to do it. Some of you just kind of made some things up, did your own new math. Okay, that really didn't work, but it's okay. You were trying. Okay, so I just switch. Remember that we're thinking f of x is our y, which we turn to x. And the 2x becomes 2y, and this x plus 3 becomes y plus 3. Then we start solving for y. Okay? So if you have multiple y's, get them together on one side. It doesn't matter which side. And then factor it out as a GCF. And it works out pretty easy then. Okay? So, answers to our homework. 31 was 1/2 x minus 2. Some of you might have had just x minus 2 over 2. That's okay. That's the same thing. 32 was 1/4 x plus 2. You might have had x plus 8 over 4, maybe. That's okay. Wait a minute, we did every one of them, didn't we? Right? 33 was 1/3 x plus 7/3, which, again, they keep putting it as, splitting it apart, but if you wrote x plus 7 over 3, that's okay. Number 34, you could have written x plus 8 over negative 3. If you simplify that out like the book is, it'd be negative 1/3 x minus 8/3. 35, you just subtract the 5 and divide by negative 2, so you'd have x minus 5 over negative 2. If you wanted, again, the book says negative 1/2 x plus 5/2. They just split it up. 36. It comes out to be the same thing, negative x plus 3. You could have, let's see, x minus 3 over negative 1. That would be okay too. 37 is x over x minus 2. And x cannot be 2 for that one. And 38 is 2x over x minus 1. X cannot be 1. And then 39 is x plus 1 over 1 minus x. X cannot be 1. Okay, any of those you want to go over? Maybe the last couple, similar to that one we did there. Do we understand that type now? That's a little bit tougher type. Those first 5 or 6 are pretty easy. Last couple were a little bit tougher like that one. Okay, nothing, we're all right? Okay, then today we're looking at exponential functions. That's when we have a base to the x power, to a variable. Okay? So the variable is in our exponent. Those are called exponential functions. Whoa, things jumping around on me. All right, here we go. So here's one. My base is 3. All right, so 3 to the x is an exponential function. So they'll give you values for x. So you just substitute those values in. So if I put a 2 in, what's 3 to the second? 9, right? What's 3 to the negative 4? What's that mean? You can put that in your calculator, you get a decimal, and then you could change it back to a fraction. What do we do to make that negative exponent positive? You guys remember? Make it 1/3, yeah, the reciprocal, right? Do the reciprocal of the base. So the base is 3, the reciprocal would be 1/3, and then you can change it to a positive 4. We don't like negative. We don't like negative exponents. No. It's okay when you have scientific notation, but anytime else, we always like our exponents positive. So I just do 1 to the 4th, which is always 1 to any power is 1. And then I want to do 3 times 3 times 3 times 3, which is 81. But again, you can do that on your calculator. It's okay. You'll get a decimal, which is also okay. 3 caret negative 4. You get that. 0.0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, that's because it rounded, I think. But again, if you hit math and enter twice, it should say 1/81. Okay? So either way, it's acceptable. So what do I put in for x this time? Just put pi in, right? It just means 3 to the pi. And you can put, there's a pi. If you look above the caret, you could do 3 caret, and then second caret, and there's the pi. It's 31.54. Or, I don't know if it'll change it to a fraction or not. Let's try it. Math, sometimes they don't. Yeah, so this one didn't. Because that pi, remember, is an irrational number. So 31.5, we could round it to. Okay, so that's all you're doing there, is substituting whatever they give you for x into the exponent, okay? Then you have a few word problems. don't know why this is so jumpy today. Oh, the natural exponential function. E is like pi. It's a special number. And this is how you can find it. You don't have to worry about knowing that. Okay, but, you know, pi is 3.14 is what we usually approximate it to, right? Well, E, we approximated 2.718. You actually have that in your calculator. You hit second division problem, division sign, E, and hit enter. It'll give you what it is, okay? Also, if you hit second LN here, it'll start, a lot of times we use E in a formula, okay? And that's how you're gonna use it today. They're gonna give you a formula with E in it, okay? So if you hit second LN down here, it's for natural log. We're gonna start talking about logarithms here in the next section, all right? There's our log button, our base 10 log button, and then natural log is base E, right? So if you hit second natural log, that'll get you E to the power. But if you wanted, you could do E and then caret yourself too, okay? So we're gonna use that E value in some formulas they're gonna give us in the word problem, okay? So that's, if it said X was 2, we could say, good morning.
Morning.
All right, so we'll see that here in the word problem I got on the next slide. Okay, so this is it says, this is the word problem, this is the type you'll have. It says a cup of coffee is heated to 106 degrees Fahrenheit and placed in a room that maintains a temperature of 70 degrees Fahrenheit. The temperature, capital T, of the coffee in degrees Fahrenheit after little t minutes, after 10, 15, 20 minutes is given by this formula. So I don't know how they got that formula, but somebody figured it out. Okay. You see that we have that E in here. Okay. So again, we're just going to hit second natural log to get that to show up when we plug it in. All right. It says, find the temperature of the coffee to the nearest degree 20 minutes after it's placed in the room. Okay? So, I can put 20 in for T there, right? So, I can just plug that. All it is plug it into your calculator. So 70 plus 90. Now, this is E to this power. So I hit second natural log, and I put that negative 0.0485. Okay, then I have to put times T, so times the 20. And then it started with that parentheses, so I got to close it off. That'll tell me how many degrees it is after 20 minutes when I hit enter. So it's still 104 degrees. That's pretty hot. Okay. So again, all I did was plug it in to the formula. Okay, and that was 140. All right, so they gave us the number of minutes, so we can just plug right in. Sometimes they'll ask you this, determine when the temperature of the coffee will reach 90. Okay? So when it says determine when, what is it asking you to find? The time, the number of minutes, right? Does that make sense? All right, so here's what I would do for that. I would put it in my y equals that formula, 70 plus 90 e to a power, so second ln for that e to the power, and then negative 0.0485. You don't have a t, so just use x, all right, and then close it up. Okay. And then just go to your table. All right, how do I get to the table? Hit enter, I guess. How do I get to the table again? Second graph, right? You guys know this. All right, so, if I'm right at 0, it's gonna be what, 160 to start? Right? So when you poured it in, it was 160 degrees, okay? So after 1 minute, it's 155 in there. I'm looking in this Y column when it gets to 90. So I just go down then and look for the 90. And you guys can hold yours down to get there quicker. So it looks like it's going to take 31 minutes before it gets down to 90 degrees.
Where do you get, like, whenever you figure out the ones like 70 plus 90, where do you get the 90 coming in?
That's all, they'll give you that in the word problem. They'll give you the actual formula you're going to use.
Okay.
Yeah, so that's all given to you. So if they give you the number of minutes, you just put in for T right in your calculator, right? If you wanted to, we could go back up here to 20 and get that answer too. So you could do the other one the same way, put it in the Y equals and go to 20, X, remember the X is your time and the Y is how many degrees it is, right? So you could have done it that way too for both. Just put it in the Y equals and then, use your table to find your answers. Okay? You could graph it. To graph it, I hit zoom 0 because it's going to be it's an exponential. They usually, if something's getting smaller, it's going to get cool. It's going to cool off, right? So if something gets smaller or depreciating, decaying, it looks like a L like that. If something's getting bigger or hotter or more money or something, it'll go the other way. Starts out kind of flat and takes off. Okay, so I can hit trace, all right, and just use my right arrow key and look for, 20 over here on the X for the 104. So I'm just looking at my X values. There's 20, it's 103 point something, so. Okay, or you could do this. You can go second trace value, that's the first one, and your X value, your T is 20 minutes. And there's your 104. It's kind of blinking there right there, but you can keep going and look for the 90 too. Go back to trace and look for the 90 here. So there's a couple different ways you guys can do this. There's 30.6 minutes. If I go one more, 89 and a half, there's 31.4. So you can use that calculator to help you answer these questions. But you're just using the formula they give you. But your formula will have this E value in it, E to a power. Okay? So we're going to hit second ln to get that to pop up in your calculator. Okay? And if you got a scientific one, like Maddie, it's in here somewhere. There it is. It's got the LN button with it. Same thing, second LN. You can put it in. Okay? You won't be able to do the table thing. So that's why I would use my graphing calculator. You guys got questions on that? You're just going to have a few word problems. You're going to have a few problems like this too. Not like that one. But like, these. So it's really not that tough. Just plug it in. Using the calculator to do it. All right, so there's your assignment. Shouldn't take you too long. Like yesterday, shouldn't have taken you that long. So maybe the last couple took a little bit more time. But again, continue to, do what you've been doing. Tomorrow we'll just do some practice of yesterday's homework problems and today's. I won't give you any homework tomorrow. We'll just do a few in class. And then Monday, I'll give you the practice quiz. We'll have our quiz next Wednesday. Now, again, if, Jacob's right, we don't have to come Monday, then next time I see you. After tomorrow. Why are you taking pictures of him? That's not very nice. It's very nice. Maybe he's in the witness protection program or something. You just, put a